So today I'm going to do a video on the fuel system on these trucks. This isn't really related to the build on my engine specifically. It's just that I've dealt with this stuff before and it's difficult to find good information. When you go to the forums, people are going to send you down rabbit holes that aren't really useful for diagnosing these trucks. So I just kind of wanted to, since I've got a little bit of free time, I wanted to do a little video on this and hopefully kind of dispel some myths and keep you guys from wasting time and money that I've wasted on these trucks trying to find fuel problems before. So first things first, these are direct injection engines. So you've got injectors going directly into the heads like you would have the spark plugs. That's not as common in US vehicles. Most stuff here, Hemis and LSs, they're still port injection, and the same is true of the 4.2 and 4.4 second gen AJs. I think the third gen Coyotes went to port injection, but you'll see a lot more, like with BMWs and Toyota engines, they use a lot more port injection than we do. The only real complication that adds to this system is that you have to have two sets of fuel pumps to get your pressure correct. And we have a low pressure fuel pump in the tank that is going to send fuel from the fuel tank up to the high pressure pumps. So I'm going to jump over here to the truck that I have separated real quick to just show you what I'm talking about here. So just so you guys can kind of see where I'm working here, here's the transmission. I'm going over here to the fuel tank. So here is your sending unit. If you look above us here, you see there's no access from inside the cabin. That's true of the LR3, the LR4, and the Range Rover Sport. The L322 Range Rovers, you can access these from the cabin. At least some of them you can. I don't know if all of them you can. Some of them you have an access port there and it makes life a lot easier on you, but if you guys have one of these trucks, you're dropping the tank if you need to get to this thing. So it's fairly easy to get to once you've dropped the tank. If you guys are having to siphon this tank out, I know a lot of people have said the fuel filler neck is hard to siphon out of these. What I would do, let's see, I need to follow the correct fuel line. Okay, here it is. If you guys are trying to drain this tank, what I would do is I would come to this junction right here at the very front of the fuel tank, take that apart, and then just jump your relay and pump your fuel out that way. You're having to take this off anyway to get this fuel tank out, so you might as well do it that way and do it the easy way. And then there is a low pressure fuel sensor on these that I will talk about in just a second. But to get to that sensor, we're going to follow this line up here a little bit farther. Here's the side of the transmission, and we're going up here real close to where your shift cable is attached. This is your low pressure fuel sensor right here. To access it from the bottom of the truck, you're probably going to have to take off this heat shield. I have it loose here because I had to take it off to get the engine out. I think if you're coming from the bottom, you're probably going to have to take that thing completely off to get to your low pressure sensor here. And if you're needing to confirm your low pressure fuel pressure, you're going to have to take this sensor off here and then plug in a real fuel pressure gauge right there. So you guys can see the low pressure system on these is pretty simple. There is a purge valve and you have your return lines there. The purge valve, sometimes they do stick open. Usually that's going to manifest as a fuel rich problem. If your fuel trim is negative, negative 20 or higher %, then I would disconnect your purge valve and see if that fixes it, or see if your purge valve's sticking. But otherwise, everything on the low pressure system is pretty simple. That sensor that I showed you there, the problem with the gap tool, which is what probably 90% of us, myself included, are using when we're working on these trucks, is that you can see that sensor in the gap tool, but it only shows you in voltage. So I'm going to jump out here in it's a 2011 Range Rover Sport. It's a naturally aspirated 5-liter. I'm going to jump in here real quick and just show you a video of the startup on the, I'm going to show you the high pressure, the desired high pressure, the desired low pressure, and then the voltage that sensor puts out, so that you guys can kind of see what to expect it to give you. There's a good chance that if you're having a hard to diagnose low pressure fuel pump problem, you're going to have to go in here and put a manual fuel pump pressure gauge on it to see what your actual fuel pressure is. But hopefully this will give you the information you need. On startup, this thing should run at 106 PSI, and that's going to be, it should be triggered, I think, when you open the door, or maybe, I think it's before you hit the start button. I think it's when you open the door is when it turns that pump on. And if you guys think you're having a low pressure pump problem, usually your low pressure pump is going to cause a crank no start. If your truck won't start and you think you have a low pressure problem, what you can do is go into the gap tool and run a fuel prime procedure. And what that's going to do is it's going to kick that pump on. And if everything is sitting quietly, you should really be able to hear that pump kick on the right side of the vehicle. It'll kick on and run for about 30 seconds or so. If you do that and then start the truck and the truck coughs a little and then starts and runs for a few seconds and then dies again, you probably do have a low pump problem. And that prime procedure managed to build up enough pressure that the high pressure fuel pumps got the engine to fire up, and then that low pressure pump couldn't keep up and it stalled out. So that's pretty much the low pressure system in a nutshell. It's not complicated, it's not difficult, but it's usually a pretty hardy system. There's not a whole lot of problems you have with it. If your fuel pump dies, it dies, and usually it's pretty easy to diagnose. So I think I've got all the information on that I've posted up here already, so I'll go ahead and move on to the high pressure side now. Okay, now onto the high pressure side. The whole point of the low pressure system is to just pull fuel and supply them to these high pressure pumps. Where this has to run between 60 and 106 PSI, the high pressure side has to run between 500 and 3000 PSI. So because of that, they went from electric fuel pumps back to mechanical fuel pumps, and they put two of them on the side of the oil pan. So my guess is that Land Rover went to Bosch and they supplied these high pressure fuel pumps, and one of them probably either couldn't supply the pressure or the volume that's needed for all 8 injectors to work correctly. So instead of paying Bosch to produce a new fuel pump for them, they just strapped two of these things on there to share duty. But they ride on this camshaft that's driven by the lower timing chain. This has to be timed to the lower timing chain, and to do that, you're going to use this tool that replaces the crankshaft position sensor that you have in your timing kit that we'll use more in the video later on when we do the timing, and then this tool here. This is just a flat bar, and then it's teardrop shaped, and it's going to fit into the front of the oil pan. So what you'll do is you'll set your crankshaft with the key at 6 o'clock. You're going to fit this into the crankshaft position sensor hole, and it's going to lock into your flywheel. And then you're going to take this tool, and it should be able to plop into the hole where the vacuum pump is. So it'll lock into this keyway that's in this camshaft, and I'll show you the front of the oil pan here. If it is locked at top dead center and this fits in, then Land Rover says that your engine is timed. So here is the front of the oil pan. You can see this tool, the camshaft would be right here. If you can drop this tool in and it fits like that while it's at top dead center with no problem, then you're good. If you try to fit this in here and it doesn't fit the camshaft, then your fuel pump is timed wrong. But there is a lot of misconception about timing the fuel on this engine. So I'm going to go over to the motor here and show you where there's a lot of confusion around this.
Okay, so there are a lot of people that are going to tell you that if you have misfire problems, global misfire problems, or any kind of fuel problems, the first thing everybody's going to tell you is that you have to come in here and check your timing on your fuel can. And that's not a bad thing to check. You need to go, like I said, go to Top Dead Center and try this tool. It's like a $20 kit on eBay. The cheap eBay ones, everybody I know of that's used them has had no problem with them. But you're going to take that tool, you're going to get your camshaft set at, or your engine set at top dead center, and it plops in here, and it's going to say that you're in business. And then there are people that are going to tell you, well, you need to look at the FoMoCo logo on the front of this camshaft, because if the FoMoCo logo is upside down, then your fuel pumps are timed 180 degrees off. So I want to show you guys what they're talking about here. You can see here the FoMoCo logo. They're saying that when you time this thing, you need to drop that tool in here and make sure that it's correct. And then you need to look at this logo and make sure that it's right side up. And if your logo is upside down like that, then that means that your engine is 180 degrees off time. But I want to show you something real quick. The way that this fits in here, it's just a flat bar. So we can take this tool and we can fit it in like this, or we can take this tool and fit it in like this. There's no orientation that matters on this timing tool. And I can tell you from experience that there are a lot of these engines out there that were timed, what people are saying was 180 degrees off, that ran for 200,000 miles with no problems. So what you're doing here is you're going to go into this engine, you're going to have to take the entire front timing system off because this is the furthest chain back, and you can't get enough slack in this tensioner right here to take this chain loose and correct your timing without taking the other chains off. So that means pulling your valve covers off, locking your cams, taking your chains off, taking the tensioners off, and stripping it down to this back chain to get enough slack to be able to time this fuel camshaft. And what's going to happen is you're going to spend all of this time going in here. You're going to take this loose. You're going to correct your camshaft timing here by 180 degrees. You're going to put it all back together, and you're going to start your truck up, and you're going to have the exact same problem, because this does not matter on these vehicles. It matters that you're timed to the right tooth, but you can have it timed either direction 180 degrees, and it doesn't matter on these engines. The first reason I say that is because this tool is not keyed in a way that matters which way these engines go in here. If this mattered, Land Rover could have made it to where one of these slots was smaller than the other, so this tool only fit in one orientation. The other thing that makes me pretty confident that there's no problem with this is this line right here. This lines up with a colored link on this lower timing chain that you'll see when we do the timing chain video. If I spin this thing 180 degrees, there's another one of those slots that can line up with that colored link on the timing chain. So that tells me that Land Rover and Jag never cared when these engines were built whether this thing was clocked with the FoMoCo logo up or down. It only has to be clocked on one of the two teeth that are indicated by the lines on this camshaft. Now, one of the reasons everybody says this has to be timed by 180 degrees, it has to be timed with that on the right side instead of being off by 180 degrees, is because they say, well, you have fuel pump 1 that runs bank 1, fuel pump 2 that runs bank 2. And if these things get out of phase, then you have a problem where you're not getting fuel to the right pump at the right time, or to the right injectors at the right time. And that's not how these engines work at all.
Okay, this is the other thing about this fuel system that people they put out a lot of bad information about these. And I think it comes from the fact that Land Rover and Jag label these fuel pumps as fuel pump 1 and fuel pump 2. But people will tell you that fuel pump 1 supplies bank 1 and fuel pump 2 supplies bank 2 with fuel. And I've shown people this junction here, and people still argue with me that these are isolated to one bank. But you can see here, this is the plumbing that goes from the high pressure fuel pumps down here. Up the side of the engine, there would be a motor mount here that this goes through to this junction. This goes that direction and supplies cylinders 2, 4, 6, and 8. And then this goes across to the, 1, 3, 5, and 7. And this goes across to the other side and supplies 2, 4, 6, and 8. So you can see this four-way junction here. You have two lines coming up from the high pressure fuel pumps, and you have two lines going off to your injectors. There's nothing about this junction here that limits the fuel pump to one bank. So I have my smoke machine here just to show you guys what I'm talking about. If I put this smoke machine here where one of the fuel pumps is, we have smoke coming out of both lines on this. So I don't know why there's so much confusion about how this works, and I don't know why people are so dead set that these are isolated to one bank. So I know I'm getting really repetitive in this video, but I just wanted to lay this out so that you guys can actually see how this stuff works, so you're not having to take somebody's word for it on these forums. If you're chasing fuel problems, hopefully this is helpful for you guys. Hopefully you find this video before you start spending money on stuff that you don't need, or start chasing down problems in your truck that don't exist. The only way, everything on this you can think of as one high pressure fuel pump feeding everything. It's just that these two are sharing the duty of one pump between them. Everything else is is just a common fuel pressure that's shared between all the injectors. The only way that you could have a pressure difference between any of the injectors or the fuel rails is if you have a physical blockage somewhere in this pipe or in one of the fuel rails going from this pipe. So I don't have anything else to add to this. I just wanted to do this video to kind of break it down and try to end some of the myths that are out there about the fuel system on this, because it's not that complicated. You can see this stuff being taken apart here. I don't know, everybody overcomplicates this and they make it way too difficult because they've read something online and they think they understand what they read or something like that, and they start throwing it out. To this day, I've never seen anybody that has told somebody to fix their timing cam or their fuel pump cam timing by 180 degrees and that fixed their truck. If you've done that and it's changed something in your truck, then let me know and I'll try to correct that. But so far, I've not seen anybody that have had that problem. And even this truck here has 160,000 miles on it, and it was timed 180 degrees wrong from the factory, and it never had a fuel pump problem with it. So let me know if you guys have anything to add to this. Hopefully I'll be getting parts back in the next couple days. So the next video I'm going to do is going to be more on the block, comparing the rotating assembly and stuff like that. And once I've got UPS delivering some stuff, I'll have some more information to put up on that build. Thanks, guys.